Okay, so hello everyone, welcome back to our C++ OpenFOAM on YouTube. So today we want to continue where we left off. So the last time we were talking a little bit about Makefiles. Very most basic way of using Makefile is as such, is as follows. So I have a hello world and a compile code. So if I do a make hello world, okay, it will type this code for us. If I do a make compile, okay, make, and then you do a double tap, it will look in the make file and you'll see all the available commands. So if I do make compile, it will compile my C++ code by running G++. That's the most easy way to use Makefile. But you're not harnessing the power of the Makefile yet, because there are lots of ways you can do it, and it'll save you lots of writing time and space, especially if you have like 500 C++ files to compile. Okay, so what am I talking about here? Okay, so before I do that, I want to introduce you to some things to kind of tidy up your Makefile first. And some of the syntax here. I'll be following most of the stuff on this opensource.com article called what's a Makefile and how does it work. Okay, so I'll just roughly follow, use it as a guide, but I will just make additions as and when. So basically, when we type make, what the file will be that will be run, it will be the first file in the first command inside, or your first, what do you call that, target. The first target in your make file, it will be run by default when you type make. Okay, so usually Makefiles will have a file called all. Alright, so let's go to make. So usually we don't just want to print text, right? We want to run every single command so that we can compile everything. So usually one of the targets that are used is this this target called all. And what can all do? All can actually run, okay, based on dependencies. Okay, so basically when I type all, I can actually run to both of these commands here, hello world and compile. Just let me demonstrate what that is. So basically, if I type hello world and compile here, and I save and quit, okay, typing make and I double tap, okay, make and double tap, I'll be able to run all, compile, and hello world. If I just run make as it is, it will do the echo hello world, and then you'll echo the trollolol, which is the hello world file, and then after that it will compile. So basically, if I do something like that, if I run put an all file here, it will be able to run all of these targets over here. The proper term is called targets. So it will be able to run all the targets here. Alright, and of course they basically act like functions in C++. Nothing too big there. Okay, so normally we will put an all file on top. Okay, so that's basically what the Makefile, how the Makefile is usually designed. Now, the other thing you'll notice, of course, is that it's a bit messy. You see this Makefile, we actually type in the echo hello world and echo trollolol here, which I don't want that to be around. So to get rid of it, just a tidy up tip, you put the @ sign here, and that will make these things disappear. So you can see the hello world and trollolol are done. And of course, I can actually do a cleanup file. I can actually make a clean target. So my cleaning, what I want to remove is vector 1. Okay, so I will put, okay, I won't do the dependency part first. I'll just clean vectors1. Okay, so if I do this thing called make clean, alright, I will actually remove vectors1 and that will actually clean everything up. So that's good. If I want to suppress this output, okay, so there's just some syntax. If I want to suppress this output, I can just put add over here. Can we just put add over here, and that will suppress all the output. So if I just type make, it will compile the file and then it will delete the file, which is kind of, oh, I have not deleted it yet. So it will just suppress the output. So if I wanted to delete it over here, then I'll do hello world, compile and clean. But of course I don't want to put clean there, or otherwise it makes the stuff a bit kind of redundant. It makes the whole compilation process like redundant. So okay, now you notice I'm able to put pieces of code over here, and these are known as dependencies. While these few lines of code here, they are called the recipes. So when you type in the target, when you type make, it will go and run the first target, which is all, or the so-called first function. All will look for hello world and compile. So hello world is here. So when you call hello world from this all target, it will run all the code here, and then you'll look for compile, and then you'll run all the code here. Of course, you can run it in reverse. Okay, if you run it in reverse, I guess it will do the opposite. So I'm just going to get rid of this. Okay, I'm going to get rid of this, and I'm going to put hello world. Okay, so I actually run it in reverse this time. So that's how this thing actually works. Now, if let's say I have a spelling mistake like hello worlds, all right, I add an extra s here. So the Makefile will actually look for this thing called hello world, and it will be missing, and it will stop the code from running. So this is what happens. So you see, no rule to make target hello worlds needed by the target all, and then you say stop. Okay, so that's how this thing actually works. Now, let's say for hello world, you don't really need any files to run. It will just print some output, right? So that's how this thing works. But if we look, okay, where this thing is useful, all right, where this thing is useful, yeah, forget what I said about 10 seconds for the past 10 seconds. Yeah, where these dependencies here are useful is that it can check for certain files that are needed to run a target or run the line of code. Okay, so the target's like a function and it needs some input. So before it runs its script. So for example, the compile actually needs main.c++ and vectors.c++ to run. So if I put these codes here, if I put these entries here, main.c++ and vectors.c++, you know, the Makefile will actually check for the files make.c++ and vectors.c++ in order for this thing to run. And in fact, it needs one more dependency, which is h, vectors.h. All right. Okay, it will check for these three files in order for this code to run. Okay, so that's, if I type make, it will just keep running g++, main.c++, and vectors.c++, and then you'll give the output of vectors1. All right, so that's all well and good. Okay, and now we learn how to suppress output. We learn how to make complex functions. Okay, also could speak targets that call other targets. All right. So these are targets that actually call other targets, and then of course we have some dependencies here. Now let's say for example I have another C++ file I need to include, like a 123.c++ or xyz.c++. All right, xyz.c++, for example. All right, if we do it like that. Okay, or let me put it this way. Let's say I want to compile 3 C++ files. Then I only kind of list these files as the dependencies. Okay, what is going to do, the Makefile is going to do, is going to run this G++ on all of this, but you realize that xyz.c++ is actually missing. So, okay, let me quit. So let me right click, and you see, G++ will give an error. Of course, you can use these dependencies here in the compile function actually to stop the process from happening using the make interface rather than, you know, have G++ display the error. So if I put xyz.c++ as one of the prerequisites, you'll see the output is slightly different. It says make no rule to make target xyz.c++. Alright, needed by compile. So it has to stop. So this is the usefulness of having dependencies here. So basically dependencies, you can use them in two ways. You can use it to call other targets, for example, compile over here and hello world over here. Alright, you can use them to call other targets, or you can use them to check whether there are the necessary files available. For example, if you need 3 C++ files and you only have 2 of them there, you can use this Makefile to actually go and check whether these files are available, and if not, it will throw out an error and it will stop the whole Makefile process. So this is what it's being done. Okay, now let's say you have let's say you have a very complex program of, okay, let's say you have a very complex program of 500 plus C++ files. Obviously, you don't want to have your files like so. You don't want to have your files like so. You want to have it organized in a more clean manner, right? Okay, so what do you do? Okay, so one of the ways is to go through one of the ways is to go through, you know, use the tricks that we have been learning in the past few minutes to do something to help in the compilation process. Now, what do I mean by that? Okay, so take for example, you have 500 C++ files, and then you want to change one of these C++ files, right? You want to change one of these C++ files listed over here or listed over here. All right, so if you change one of these C++ files and you use this sort of way to recompile, you're actually recompiling all 500 C++ files, and then you are wasting a lot of CPU power. All right, if I only want to recompile one of these files, all right, if I only want to recompile one of these files, there is a trick you can use. All right, so before I go into the automating it, I want to show you the make G++ command. All right, G++ command. So if I actually do G++ main.c++, it will throw an error because there are references that you need in the vectors.c++, right? So you can't do that. However, if I do G++ C main.c++, it's okay. It will give it will not check for any of these errors, right? Because it will not check for any of these errors. It will just give a main.output file. So basically, main.output, all of this is just binary code. That's why it's giving you this funny pattern here. Okay, it will just compile whatever is in main.c++ without checking for how the codes are linking together and everything. So you can actually do a partial compilation. You can compile the C++ files one at a time, rather than you have to redo all of your 500 files. So this is the useful part. Okay, so now that we know how to partially compile the files, all right, we can, so now we know how to partially recompile the files. And let's say if you have 500 C++ files and you just want to edit one and recompile, you don't have to recompile all 500 files. All right, so Yeah. All right. Oh yeah, I kind of missed a step there. Sorry. Yes. Once you do your G++, you have to put a flag -c main.c++. It will give you the main.o file, and then what you need to do also is to G++-c vectors.cpp. All right. Okay, vectors.cpp, and it'll give you a vectors output file. If you change your vectors, if you want to compile them together, you need to G++ main.o and vectors.o, and you'll give the output of vectors1, for example, and then it will run and it'll give you this vectors1. So these output files, these are so-called, like, I guess you can call them intermediate files or whatever, but yeah, these are the .o files that you're talking about. These are basically object files. So instead of using main.c++ and vectors.c++ as our dependencies, we'll want to use vectors.o and main.o. So this will help us to partially compile the files, and this is what this guy here was actually talking about. That's why he has his C++ file like that, and that's what I'm kind of following. All right, before I kind of go into this other examples here, there will be lots of other stuff here like variables. We'll talk about that later. Okay, so let's say you want to have a main.o and vectors.o as your targets, and you know this one will compile everything there. All right, you'll compile everything there. Okay, so I'll just quickly run through it because if you want to see more, you can go and take a look into this Paul's Programming's videos, because I don't want to like repeat what he's saying, but I'll just quickly run through. All right, then I'll go on to other stuff over here. All right, so I'll just quickly write it the following. Remember, we can use these targets over here, or these dependencies here, to call other targets. So when I call compile will look for main.o and vectors.o. Okay, if main.o and vectors.o are not there, you know, they are not yet generated, they can be listed as a target. So main.o is actually listed as a target. So main.o is here. So main.o, the dependency is main.c++, because you need to use G++ to convert the main.c++ into main.o. So G++-c main.o, or C++ into main.o. So this is how it will work. So the other one is vectors.o. So vectors.o will need two dependencies. One is vectors.c++ and the other is vectors.h, and then it will do a G++-c, okay, vectors.c++. Right? Oh. Now, if we run this code, it should run exactly the same way that we were running it just now. So let's run make. So what will it do? It will G++-c our main.c++ file, and our G++-c our vectors.c++ file. Okay, and then it will make our vectors1 file. Okay, so if I do make clean, it will just remove the vectors1 file. But there's one more step I kind of want to take, because it's just my preference. I want to remove this O files over here. I want to remove them using the clean command. So main.o and vectors.o. Alright. So if I want, I can use the wildcard operator star.o, and it will just do basically the same thing. Okay. If I do a make clean, it will just erase everything there. Can you see that? So if I do a make, it will do all of this here. If I do a make clean, it will erase everything. So that's how roughly you want to work with Makefiles. So one of the things, the nice things about it is that if let's say you already compiled your files halfway, all right, you compiled your files halfway, and then you want to change something in your main.c++. All right, so main.c++, I do a bit of a change, and that change is over here. So I want to do cout change 1, okay, and then I do endline. Okay, so there's we can do a partial compilation. If we just want we can do a partial compilation using this code. And what G++ will do, I mean the Makefile will do, is that it will find main.cpp. Main.cpp has been changed so that it will just do the partial compilation, but it will also look for vectors.cpp and vectors.h. So that one, if you did not compile it properly, I mean, if it's already been compiled, it will not recompile them again. So it kind of saves you time there. Okay, so that's basically what this does. And again, if I run the make command again, it will not rerun the compilation steps of the main.cpp and the vectors.cpp. It will just combine these two output files together as one output file. Alright, so that you can just run vectors1. Okay, so and then it will do it properly. Okay, so now before I end, I just want to quickly, I'm almost running out of time, but before I end, I want to quickly introduce you to something called variables. Okay, variables. So basically, if you want to kind of automate the process of making your files, okay, then you want to use something called variables. Okay, what are variables? Variables are basically, if let's say let's say you have a generic C++ folder, right? You have a generic C++ folder with many files of whatever name, right? So what you want to do is to so-called automatically get the names of all these C++ files, and then you want to compile them. So how do you get the names of these files? All right. So again, if let's say I have a vector C++, a main.c++, vectors1, vectors2, arrays.c++. Let's say I have 7 C++ files, for example, right? How then do you automate the compilation process? So before, you can actually define the variable here, okay? And this is under patterns and functions here. I'm just showing you the wildcard part. So when you see this colon equal here, that is basically a way of saying, we are just defining a variable. Okay, there are two ways of defining variables. One is that you use the equal sign, which is basically the way we are normally quite used to. But we can also use this colon equal sign, which is called an expanded variable, and it will prevent certain errors from running. I will not discuss what they are, but it's just a safer way of defining variables. So let's do srcs. We'll use this code here. Okay, and that will actually capture. It will capture every file that is named that is a C++ file. Okay, star.cpp. Okay, it will look for all the C++ files here. Okay, and we want to put it under list C++ files. Okay, so what will this do? This will actually list all your C++ files as per what the target is saying. Okay, so it will list the C++ files. And how will it list the C++ file? Okay, it will just echo, and I need to echo this variable called source. And when you want to echo this variable, you need to put the $sign and the brackets there. Okay, as per what I'm doing, you need a $sign and brackets to echo this variable. Okay, or actually you need curly braces. Okay, so if I quit this and then I type make echo, okay, list C++ files, it will list the C++ files as vectors.c++ and main.c++. So how does the Makefile actually work? It will read from the top, okay? It will store all the C++ files. As long as it has a C++ extension at the back, it will store all these files in this source variable. Okay, once you do that, when I type the list.c++ files, the make list.c++ files, it will echo all of these C++ files. So you can see this is actually is getting more and more powerful. You're getting into scripting the compilation process, which is why the make file is so powerful. Right, so I'll stop for now. I'll see you guys next time. Thanks for watching.